This is problem 6 from the 2004 AP exam for the free response. Now problem 6s again are always going to be a little bit longer problems, so there's going to be more parts to them, so this one might take a little bit. Starts out saying a pharmaceutical company has developed a new drug to reduce cholesterol. Regulatory agency will recommend the new drug if there is convincing evidence that the mean reduction in cholesterol level after 1 month of use is more than 20 milligrams per deciliter, because a mean reduction of that magnitude would be greater than the mean reduction for the current most widely used drug. So there's some drug out there that helps patients this much, helps reduce their cholesterol by a certain amount, and what we're saying is that if this new drug can do better than that, then this new drug will be approved for use. Otherwise it will not. Pharmaceutical company collected data by giving the new drug to a random sample of 50 people from the population of people with high cholesterol. So the population is being defined as people with high cholesterol, and then it was a random sample of those people, and 50 people were in that sample. The reduction in cholesterol after 1 month of use was recorded for each individual in the sample, resulting in a sample mean reduction in standard deviation of 24 milligrams per deciliter and 15 milligrams per deciliter, respectively. And so let's try to label what these are. They're talking about means again, so we're looking at mu's and x bars. So the sample mean reduction of 24 is our x bar. We have a sample standard deviation of 15 right here. That's our sx, so let's label that. The evidence that they're looking for is that the mean reduction level after 1 month of use is more than 20. So we're talking about mu being greater than 20 here. And if we scroll down to our actual question, I'm assuming it's going to be something about hypothesis test based on the way things have been worded so far, but it says the regulatory agency decides to use an interval. Okay, so it's not a hypothesis test. The regulatory agency decides to use an interval estimate for the population mean reduction in cholesterol level for the new drug. Provide this 95% confidence interval and be sure to interpret the interval. So first thing we're going to do is we're going to be using mu, which means we need to define what mu is. So I always start out with those definitions. What exactly are you referring to? Mu is going to be the mean reduction in cholesterol in population. And so you always want to say all of that. What it's referring to. It's the mean reduction in the cholesterol in the population. Then it says you're making a confidence interval. And so a confidence interval, whenever we don't know sigma, the population standard deviation, we know S, the sample standard deviation, is always going to be a t-interval. So we're going to say that mu is equal to, x bar plus or minus t star, that's our critical value in this case, times whatever our standard error is, our standard deviation, divided by our square root of our sample size. You always want to write out the formula, because writing out the formula, one, lets them know that you are doing a t-interval of a mean with an unknown standard deviation, and it also lays out what steps you need to take next. So first thing you want to do is figure out what values you're going to plug in here. We already found x bar, we already found s. Our sample size was a sample of 50 people, so sample size n is going to be 50. And then we have everything but our t star. If we go here and try to figure out what size interval we're dealing with, it says provide a 95% confidence interval. Well, to do a 95% interval, if we had a way to look up our t-star, that would be fine. Otherwise, we'll have to calculate it real quick. And t-distribution, we know, is based on how many are in the sample. So if 49 are in the sample, our degrees of freedom is going to be 49. 50 in the sample, degrees of freedom. We subtract 1 from that value, and that will be useful when we're doing that calculation. We know we're finding the middle 95%, which means that on each end we're finding 0.025 because we have 5% left over, and it's 2.5% per side since it's symmetrical. So we do our inverse normal in our calculator, and this is something that I'm going to write out right now so you can see it, but you actually don't want to write that out on an AP test. They don't want to see anything that you would plug into a TI calculator. They call it TI speak, and they get really crabby about it. So just leave that off. So inverse t, not inverse normal because it's the t distribution of 0.025, that's the area under this left side, comma 49, our degrees of freedom. And if we type that into our calculator, we're going to get a t value, t star, of 2.010 if you round that properly. 2.010, and that's a tough one to round. 2.00957 coming out of the calculator. So we round that off. Usually 3 digits will be fine for a t-star value on the AP problems. And now we have to plug in all our values into our formula. So let's go down here, and we have mu. Mu is what we're trying to figure out, and it's equal to our predicted mean, and it's written over here, but it's a 24, our x bar, plus or minus the t-star value we just calculated, the 2.010, times our sample standard deviation of 15 divided by the square root of our sample size of 50. So that is going to be mu is equal to 24 plus or minus, and if we multiply that out, we get 4.26. So 24 plus or minus 4.26 is our interval. Now going back to our question, let's make sure we answered it. Regulatory agency decides to use an interval estimate for the population mean reduction in cholesterol level for the new drug. Provide the 95% confidence interval. Be sure to interpret the interval. And that interpret the interval is creating one of those sentences that everybody loves to write, being as specific as possible about what we're actually finding here. So the thing that we are finding is that the mean reduction in cholesterol in the population, that's what our mu is. So how confident are we in that estimate of the mean reduction? We're 95% confident. So we're 95% confident that the mean reduction in cholesterol in the population, and we always want to say what our population is, of high cholesterol patients, or high cholesterol people, is, and then we state what it is right here, 24 plus or minus 4.26 milligrams per deciliter. Let's put our units on there because that tells us what we're referring to. Is 24 plus or minus 4.26 milligrams per deciliter. And I believe that we have everything. We have how confident we are, confident in what? The mean reduction of cholesterol, who we're talking about, our population of high cholesterol people, and our actual answer, our interval with units on it. So that should be a correct interpretation. Now let's go on down to the next part here. I'm going to write up our interval from what we had before. We had our estimate of 24 plus or minus the 4.26. And this will be referenced in just a moment. Because the 95% confidence interval includes 20, the regulatory agency is not convinced that the new drug is better than the current bestseller. Pharmaceutical company tested the following hypothesis instead, and then it has a hypothesis below, and we'll get into that in just a sec. Before we do that, it makes a claim that says the confidence interval includes 20. If you were to write this out in interval notation, and you actually did the 24 plus that number and the 24 minus the 4.26, you would get 19.74 to 28.26. So that range includes the number 20. 20 just barely sneaks into the edge of that range, and that's what they're referring to there. So it says the pharmaceutical company tested the following hypotheses. The null being that mu is equal to 20 versus the alternative that mu is greater than 20, where mu represents the population mean reduction in cholesterol level for the new drug. The test procedure resulted in a t-value of 1.89 and a p-value of 0.033. Now the t-value is kind of like that z-score, and the p-value is the area under the curve, as we know. Because the p-value was less than 0.05, the company believes that there is convincing evidence that the mean reduction in cholesterol level for the new drug is more than 20. Explain why the confidence interval hypothesis test led to different conclusions. One thing that's pretty interesting about this question is it brings up the relationship between a test and an interval. Let's say you have a 95% confidence interval. If you did that and you had to figure out what was left over on the ends, you would have 2.5% over on this end and 2.5% over on this end. On the other hand, if you were to perform a hypothesis test that is a two-sided, so it was a not equals test, and you wanted an alpha value of 0.05, you'd be looking for p-values that are in the range of 2.5% on this side or 2.5% on this side. And that means that it would not fall in the 95% in the middle. So if you have a 95% confidence interval and something is inside of the interval, that means that it would fail to be significant. It would not be significant. You would fail to reject if you were doing a not equals hypothesis test over here, because it would not fall in the far ends of the normal curve. So because it's in the middle 95%, it can't possibly be in the outer 5%. That means the p-value cannot be less than 0.05. And that's what this question is starting to get at. And yet, despite all that, it says they ran their test and they got a p-value of 0.03. Now the way they did that is they did not do a two-sided test. They did a one-sided test. They said mu is greater than 20. So what they were looking at on their curve was the 5%, the alpha value was actually up here. And the left side was 95%, and the right side here, the right tail, was 5%. So yeah, their value was able to squeeze in here to this one side, but it wasn't enough to squeeze into the 2.5%. This p-value of 0.03 is going to be between 2.5% and 5%. It kind of squeezes in that little tiny gap. Which means that if you run a one-sided hypothesis test here, you will get a conclusion that says reject the null. And if you do a two-sided test here, you get a conclusion that says fail to reject. And that's why the pharmaceutical company and the regulatory agency got different results. So let's just clear this off here. Explain why the confidence interval and hypothesis test led to different conclusion. You could say something to the effect of a confidence interval is comparable to a two-sided test, hypothesis test. You would want to say where a 95% interval corresponds to an alpha value of 0.05. because if you see, the 95% is saying where it is, and the 0.05 is saying where it isn't. So you add those together and you get 100%. So 95% interval corresponds to alpha is 0.05 on a two-sided hypothesis test. The reason they got something different is that the conclusions are different because the company ran a one-sided test. So the conclusions are different because the company, I'm abbreviating a lot here, but you probably should just write it out. The company has ran a one-sided test. And that should be sufficient to get your point across. With AP, it's not bad to be a little bit overly talkative if you can more clearly explain exactly what you're thinking. However, if you say anything that is incorrect or not true, they're automatically going to nail you for points. So don't get any more rambly than you need to. As I always like to say on my free response, give me the shortest correct answer possible. It's just that sometimes in AP questions they do want you to elaborate a little bit to be fully correct. Now part C says the company would like to determine a value L that would allow them to make the following statement. We are 95% confident that the true mean reduction in cholesterol level is greater than L, whatever that amount is. A statement in this form is called a one-sided confidence interval. And now this is something that's not really part of the AP curriculum. This is something where they're taking a concept that you already know, such as confidence intervals in general, two-sided confidence intervals, a typical one that you would normally see, and they're trying to stretch you a little bit. So they're saying, you know how to do a one-sided hypothesis test, you know how to do a two-sided interval, we're going to try to see how you handle something new. And that's not something uncommon in those problem number 6s. They might try to stretch you in new ways. So we have this L equals x bar minus t star times s over square root of n. It says this has the same form as the lower endpoint of the confidence interval in part A, but requires a different critical value t. What should be used for t star? Now you have to figure out how you would choose a t star here. It says a confidence interval, it is one-sided, and they are 95% confident that the true mean reduction in cholesterol level is greater than a certain amount. So if we drew ourselves our normal curve here, 95% chance that it is greater than some amount. The 95% thus is on the upper end, and on the lower end we have only 5%. If we want to find a t-star value, we can do an inverse t, and we're going to find the lower 5% of the t distribution. And our degrees of freedom is going to be the same as what we had earlier based on our sample size. And our sample size was 50. So we're going to use a degrees of freedom of 49 once again. And when we do our inverse t, again, that's not something you want to leave written on your paper, but you can write it for yourself. Inverse t of 0.05 comma 49. That's going to give you the t value that occurs at that point. And usually we ignore the negative sign on those. In this case, the negative sign is built in for us right here, so we can, again, not have to worry about it in this context either. And the value that we get is going to be 1.677, if you round that off, 1.677. It says recall that sample mean reduction cholesterol level and standard deviation are 24 and 15. Compute the value of L. Well, we know all of our information now. So L equals our x bar of 24 minus our t star of 1.677 times standard deviation of 15 divided by the square root of 50, and that's going to equal, plug that all into our calculator, and we can actually finish it off this time because it's not a plus or minus, it's one full thing, so type the whole thing in your calculator. Comes out to 20.44. Says if the regulatory agency had used the one-sided confidence interval that was used in Part C here rather than the interval in Part A, would it have reached a different conclusion? Yes, it would have. Now, why did it reach a different conclusion? Because the lower end of this confidence interval says we're 95% confident that it is the reduction is this amount or greater. And that amount or greater is greater than the 20. The 20 is what they're trying to clear, that initial hurdle. So doing this was kind of like doing a one-sided hypothesis test. Same idea with this weird one-sided confidence interval that they threw at us. 20 is no longer included in the confidence interval. So that is our main reason that 20 is no longer part of that.